Hey everyone, I am Ali. I did the first workshop over here, and I think this is the last workshop for that the Curious is doing. So it's kind of poetic, start and finish. So I'm going to be today talking about one of the most interesting technologies that are used called Dockers. So some of you guys may have heard of Dockers and how it's used. I'm sort of going to be splitting up this workshop into two separate parts. The first one will be going over the theory, the how, the pros, the cons, and why it's better than traditional deployments and how it's been done in the past. And the second half is going to be focusing on the actual practical aspects of it. So I think I'll be able to go through the theory like relatively quickly. This is going to be an hour and a half workshop, hour and a half long workshop. So I'm only going to be maybe I might end up having some extra time. I'll either do questions or I'll go to the practical part. We'll do a vote at the end just to see like who wants to do what. Yeah. So let's get started with Dockers, right? So Dockers, the last thing we'll probably ever install. So the main concept of Dockers stems from how deployments were done traditionally, and by deployments, like I hope everyone over here is familiar with deployments. Like throughout the workshop, I am going to ask some of you people to just answer some questions so that I can sort of like get a good feedback from everyone in the group and sort of like not just be talking about some weird stuff and like you guys are all like, hey, we have no idea what this guy's talking about. Yeah, so please do let me know if you have any questions or like if I ask questions, just like answer them in the chat so it's easier for me to follow along. So deployments are essentially, it's kind of hard to describe now. It's not actually that hard. Deployments are, sorry about that, give me 1 second. So deployments are ways in which you can launch your service so that it works. That's a terrible explanation. So moving on. Traditionally, when you want to build something and you want to put it into production so that other people can actually start using it and building on top of it, let's start from the beginning. So let's say you and your friend are two programmers, and what you guys want to do is essentially you guys have an app that you guys are always working on and developing on, and you're like, hey, we finally have some good customer support. We should definitely like put it on the internet so that people can actually start using it. So you write up your code and you put it on the internet or host it on a server. That is a form of deployment. And that makes sense, right? You just you write your code and then you run it on the server. That's pretty good. What if, say, you start adding like 3 more features to it? And then you're like, hey, our server is getting a lot of traffic. We should start monitoring people's usages. So what you start doing is you set up a database to sort of track that usage going on. And then like, oh, we need to like start taking logs just to make sure that stuff is actually working and bugging. So like you set up a logger, and then you start doing all these different things that are all working together. And you suddenly realize, hey, this is really complicated to manage on our own. And how are we supposed to do this? Because it's like a huge pain to like do it every single time. And that was actually a really common problem that people saw when they were working on traditional deployments, which was essentially you have a bunch of massive servers that are like, that have like 20 cores and like 64 gigabytes of RAM. And what you're trying to do is essentially you have multiple virtual machines running on it. And each of those virtual machines, say, the first one is running a database. The second one is actually hosting your website. And the third one is the logger or something else, or some other stuff that you might be having. And all of this is running on a pretty heavy system because firstly, at the bottom, you have your actual physical servers that you do stuff with. Then your hypervisor, which is a software that can sort of monitor and work with virtual machines. Then inside the virtual machines, you have an operating system, which is on its own pretty heavy. Like my laptop over here sometimes just doesn't even run sometimes it just breaks down when it's trying to run Windows. Like how is it supposed to run a massive system? And this is a decent laptop too. And then you have like all of this bloated stuff on top of this on top of this heavy server just to run a single database. You could definitely like merge all of them together, but that brings us back to the problem where like you're trying to like manage all of these things together, and that's just a headache. So what a lot of smart people end up coming up with is that, oh yeah, this is just specifically talking about virtual machines themselves. And now sometimes like they merge the two apps together just to get them to interact with each other. They're isolated from another, and you see that there's the operating system repeating multiple times, which is super annoying. So the way modern deployments work is that, let's say you and your friend are working on that app and you're like, hey, I just fixed this bug. So a couple of steps are generally bound to happen as you push it to the production server. And what that sort of does is that it goes over a continuous integration, continuous delivery pipeline. I'll go into a little bit more on what this is and how Dockers affects it, but I'm going to be primarily talking just now for Dockers themselves and how they handle the problem we just brought up a couple of slides ago, where you have this massive bloated system and they're all trying to work together, right? So before I do that, does anyone have any questions on the traditional deployments? Because I'm kind of going a little bit fast, but let me know if you have any questions. No? Silent? All right. So, the way Docker sort of handles this is essentially, hey, why are we packaging an entire virtual machine when we just need to properly package just whatever we need inside a box? Does that make sense? I hope it does. So what that sort of means is, like, instead of having an entire operating system running on a virtual machine, what you then have is your servers, whatever operating system you're using, Windows, Linux, Mac, and then you have a Docker server, which essentially talks to the operating system itself on the kernel level, and then on top of that, you just have your containers. What these containers are, they are essentially your app, and what they do is that they store important files. For example, it could be like on a single machine, I can have my database, and I can have my website, and then I can add more and more stuff along this as time goes on, and I need to sort of like start building it more and more. And let's say like my computer, like this thing sort of starts becoming a little bit too heavy to manage. So Docker then has functionality to enable networking between these different servers. So you can have like 10, 20, 100 different servers, and they're all talking to each other through Docker's orchestration and even Kubernetes, which we won't go into today, but it's still an important. It works with Docker's in the similar vein. So just sort of like explain a little bit more how Dockers work. It's a very common analogy that's used is how they're used in comparison to there's a reason why they call it containers, and the reason is because traditionally, if you wanted to ship something from China to Montreal, you buy something off Ali Abbas and you're like, man, I really want those cheap Chinese deals, but that's going to take like weeks. And I hope this really sensitive part that Stephen gave me during my courier's workshops, I hope it doesn't break while it's shipping here. So this was a pretty big problem because they had all of these different things back before containers became a thing, where they wanted like ship cars, servers, oil, barrels, and I'm going to assume that's dates, pianos apparently, and some other stuff and so on. So how did these goods interact with each other if I were to just put them on a boat and just let it go? So it became a huge hassle. So what a lot of people figured out was that let's just have a box which contains all of our which is going to contain everything we want to ship out to Montreal, from China to Montreal, and we're going to handle everything. Like, let's assume all the boxes are the same. Like, some of them could be heavier, the others can be lighter. Makes sense, right? So let's assume that all of them are the same. So it goes from, oh, I have a car versus I have a barrel of oils, to I have one big box that's the standard across all boxes, and I want to ship it. So that, it just makes it easier to ship things overseas and all that. So and then when you're sort of like working with all the when you're like putting thing from A to B, instead of shipping a car, you're shipping a box. I hope that sort of made it easier to sort of like follow why Dockers are so cool now, is because like now I don't need to spend 40 minutes installing a Minecraft server. I can instead do it in 5 with I said 40 minutes or whatever minutes. But instead of that, I can just ship it directly. I can just install it directly with Dockers and do Docker run Minecraft server. And it just works out of the box. I don't need to worry about it. And I can manage all my operations and servers and all that using just this one piece of tech, just using this thing. And I don't need to worry about too many things. Maybe some configuration stuff is going to come up, which it usually does, and it's usually an important part for the deployments. But once I have that ready and shipped, it's working right out of the bat without any problems at all. So this is how the two of them sort of work together. Yeah. So I have my containerized applications, and what I'm sort of doing with them is I have, as I've gone over before, I have my infrastructure, I have my host operating system, I have the Docker layer, and I have app A, B, C, D, E, F. And then on the other side, we have our virtual machine on the same underlying infrastructure, and it's not able to hold as many things because of how bloated it is in comparison. So that's sort of how Dockers tend to be different from one another. Like how Dockers are essentially better than deploying stuff on virtual machines, because virtual machines by their very nature are super, super heavy. Yeah. Any questions at this point? Anyone? Can someone just like actually like type in the chat whether or not I'm doing a good job or whatever, so I actually know that you guys are able to follow? Thank you, Panther. Your noise is very well appreciated. Thank you. All right. All right. If you guys have any questions, just put it in the chat, and I'm more than happy to answer. Moving on. So I did promise you guys that we're going to be looking at how deployments themselves work. So generally, now let's say person A and person B, Steve and Bob, are working on that app we just mentioned. They have they have 6 containers, and essentially they have 6 pieces, like a database, logger, unit testing machine. I'm just making stuff up, but you sort of get what I'm going for. And so on and so forth. And essentially how these, so essentially how I want to test whether or not when I make a push to the database and how it works. Yeah, well, when I make a git, okay, so let's say you have the whole thing set up, A to B, starting from from developers developing and they actually deploying the stuff to production. So what ends up happening is that let's say you have a git push. So let's say you guys come up with a new feature that comes up, and it's like a really cool feature. It makes sliced bread look bad. So what you guys end up doing is you add the new feature, and you're like, hey, this is going really, really well. And then you immediately choose to say, what if this destroys every single thing we've built so far? And from both a developer's perspective as well as a businessman's perspective, you kind of want to avoid that for fairly obvious reason. If you need me to explain why, I'll be more than happy to. So what a lot of smart people, smarter than me definitely, came up with was that they said, hey, let's create a system so that whenever you push your changes to the master GitHub repository, what ends up happening is it automatically checks whether or not your code is working, and like it's not going to destroy everything in the universe and cause you to cry. That's exactly what they do. They essentially just so what ends up happening is that that's where the overall deployment pipeline ends up coming into being. What they do is that you push your code directly from your local machine or workstation to a common GitHub repository. GitHub's job is then to compile it and then run Docker build on it. So when it compiles your code, let's say it's a Python file, you just need to make sure that the syntax is valid, because Python is pretty amazing that way. You don't need to like worry about compiling anything. Yuck. And what ends up happening is that once it's compiled, we know for a fact, hey, this is something that does work, its binaries make sense, blah, blah, blah. And we know that there are no major issues in this, and we can actually like start doing some stuff with it. So then Dockers is going to build that image and like make sure that on any environment that it goes to, from testing to deployment, staging, and production, it's going to work like a charm. After oh, by the way, this is the continuous integration and continuous deployment pipeline I was talking about, in case you guys missed that. All right, so compiles it, Docker builds it, and then this Docker build goes into the test chamber, the testing environment, where essentially what ends up happening is that there are a lot of automated tests run. I know it seems kind of counterintuitive. Hey, I'm writing code to make sure my code works, and it's like, but should I write code to make sure my code that makes sure my code is working? Should I write code for that code, or should I not? And so on and so forth. Well, ideally you don't, but if you do, let me know how that goes, because that's really rare. So it runs a bunch of different tests. The unit test, for example, is making sure that every single part of your app is functional and does exactly what you want it to do. So let's say you have an addition app, and what it does is that it makes sure that 2 plus 3 is equal to 5. And you have a function that says add a comma b. So what you do in the unit test is that you literally call function add, and you give it 2 comma 3 and assert that add 2 comma 3 is equal to 5. And if it passes, then congrats, your unit test was successful. Great job. And you know that makes sense. It's just like good practice. You know that each individual component in the thing that you're deploying is successful. Great job. Then we have the integration test, and what that sort of means is, in this new feature that I've added to the whole system, I'm kind of hoping that it does not destroy every other app in every other thing that's already sort of working. The way you sort of do that is you literally just like plug it into a test environment and let it interact with the system, and just make sure that the things that are working how they're supposed to work are still working how they're supposed to work. I hope that made sense, right? So after it goes through all those, you also do some load balancing tests and all that. And then you go over to the deployment section, which is staging, and then production. And maybe like not all companies have a QA place. I know for a fact that EA has one. They have a really good quality assurance. Yeah, they definitely have a really good quality assurance thing set up. And yeah, so staging, quality assurance, production, and it goes directly over there. And then once it's completely done, you have it in production, and you know for a fact that it works, which is fantastic, because you've done all these tests, you've gone through the quality assurance, you've gone to the staging area. So some real fun facts about this. Can I just get some guesses in the chat with how many times a website like Netflix updates themselves? Any guesses? Like in a day? Oh, and you're not allowed to Google it. In a day, yeah, exactly. How many times do they update their website in a day? Or push changes to their system? 100? Yeah, random guess 500. It's actually like, I think in the thousands. Yeah, it deploys code once every 11.7 seconds, which is massive. Like, if you watch a trailer on Netflix, there's probably, like, the code has probably been pushed and this whole pipeline is run. Like, how long is a Netflix trailer? It essentially updates itself like every 11.7 seconds, which is crazy. And it's really, really interesting as well with how well it all works and how automated it is overall. Because, like, before GitHub existed, people would literally have to have, like, there are 2 layers of developers. First is the guy who, like, first layer of developers is like people who actually code and build the entire app. The second layer on top of that is literally a manager or someone whose job is to take code from like 10 different people and manually just like code it all together. And then when he's like, okay, I think this works, push it into production. Not a good system, right? And that's essentially how they came up with the whole continuous integration, continuous deployment, because now companies like you would never hear anyone whose job is to do that. It's insane. And it's like so automated and so powerful. Does anyone want to actually see me set up a continuous integration pipeline right now? I'm asking the chat. All right, dead. Oh, yeah, it's dead. All right. So I'm assuming no one wants to actually see that. It's kind of sad. So I'm going to go over some of the pros and cons of Dockers and sort of explain like how it essentially works is that a lot of developers ran into issues where their machine, like the code would work on their machines because of some environment variables or some configurations or so on and so forth, and they faced a very common problem. Like we have 2 developers, one's running on Windows, the other one's running on Mac. That's bad because we need both of them to be the same, and it's not economical that way. And how do you sort of manage that sort of thing? Because what works on Windows will obviously not work on a Mac machine or a Linux machine or a different variant of Linux, because there are like a ton of them. So what they ended up doing, so one of the benefits of Docker is that it sets up your entire environment so that everything is put together in such a way that everything just works right out of the box. Like you set it up with all these configurations to essentially define how the system is supposed to work, and then just push it to and that's it. And you push it to the production, or you do tests on it, or do whatever you want on it, and it just works right out of the box, which takes care of the "it works on my machine" syndrome, which is apparently very common back in the day. Finally, it makes managing environments very easy as well. This is sort of piggybacking from the previous one, but let's say you have, like, again, for the CI/CD stuff, you're probably going to wanting to be defining that your test database is definitely supposed to be separate from your staging database or staging system, which is going to be different from your production system, which sort of makes sense, right? Like you don't want the whole thing to be the same, blah, blah, blah. So what Docker enables us to do is that it lets us set up the environments so that they always talk to different to different servers according to what they sort of need. And that's pretty useful because then you don't have to like manually configure or edit strings inside a you don't have to manually configure strings anywhere at all. And strings like obviously pointing towards the databases and stuff. So then one of the other pros is isolation itself. It sort of enables you to have your application be completely separate from everything else that's working. So let's say I have these 2 things that are supposed to talk to each other, database and app. What I try doing is I have my database running on a instance and I have my app running. What I don't want is people to, like someone who examines my server to see how these 2 apps are interacting or talking to each other. So what Dockers does is that it keeps everything contained inside the container itself, and only enables like some minor connections to go through. And what that does is that you sort of have a good chunk of control between how processes are talking to each other. And generally, you'll open like one or maybe two ports on your infrastructure, and it just works out pretty well. The cons are it doesn't have a lot of GUI support. What this means is that if you're running some stuff that is, like, let's say I want to run Minecraft on it. Not the Minecraft server, I want to run like Minecraft on it. So what I generally end up doing is, like, I can run, like, I would not be able to do that because it doesn't have the proper functionality and tools to actually run a user interface. And I don't know if you've tried it, but Minecraft on just the command line, and you just like typing stuff in and getting continuous text prompt, not the most fun thing in the world. Take my word for it. Right. So no limited GUI. This, of course, is sort of changing. There are more and more functions as time goes on. They're adding to the thing, so it actually might become a possibility soon. Another con that I decided not to add on the list is Windows support, which is sort of slow. Initially, like, Windows wasn't that well supported. They finally got WSL2 working, which enabled us to have like Dockers running. So we now have Dockers on Windows. Before, we sort of had to have a Windows Professional version for some reason, and now we can run whatever we want on a Dockers environment over there. Hope that made sense. Yeah. The second con is sort of performance. So this is a bit of a weird one to sort of talk about. Yeah. So, like, compared to a virtual machine, which is super, super heavy, Dockers is a godsend in terms of performance because it's very lightweight, very, very easily shareable. It works really, really nicely, all that cool shebang. But it's still got some overhead compared to what virtual machines had. And now it's sort of like, oh, it's just a lot less. But compared to like a bare metal instance where you're running a database on the machine itself, it's working pretty nicely. Yeah. So that is more or less the theory of Dockers, or like how it all works together. Yeah. Do anyone have any questions? Because I definitely overestimated how long all this stuff is going to take. I think I'll start some of the stuff for the practical aspects of the workshop now as well. And you can sort of go over it, and I'll continue tomorrow as well. So if you guys have any questions, let me know right now. I'll give you guys like 2 minutes. All right, so in that case, let's actually start working with Dockers. Yay! So how do you install Docker? That's the first question that gets asked a lot. And the answer to that question is generally through, sorry, I'm checking for any message. So I'm going to consider the three popular operating systems: Windows, Mac, and Ubuntu. So for Windows or Mac, like, first thing that I suggest everyone do, actually Google them how to install Docker on Windows 10. So the first thing that's going to end up coming up is Docker Desktop, and yeah, install Docker Desktop on Windows. It's going to take a second, and Docker Desktop. No, that's not the site I'm looking for. Download Docker Desktop, and boom. So this works right out of the box for both Mac as well as Windows. You got to make sure that you're running on the latest version of Windows, just so that it doesn't break because it requires WSL2 to be installed. To those of you not familiar with WSL2, WSL is essentially you running Linux on your Windows machine and just cheating the whole system that is Windows versus Linux, so you can sort of get the best of both worlds, you know? Let's see. All right, so I'm just trying to show you WSL, and it's like, it says, it shows the Windows logo, but it'll say OS Debian GNU. I'll just increase the size so it's easier. Yeah, so it says Debian, and you can actually like see all the cool stuff installed. Oh, what have I done? These are all Windows files, by the way. I accidentally clicked ls. And like you can see all these cool stuff, and you can actually access your Windows stuff as well directly without any problem. So like these are all the files that I have on my Windows instance. It's all work stuff. I don't want to bore you people with it. And I can also do cool stuff with BioBoo, which is essentially just viewing memory. It's just, yeah, cool hacker nerd stuff. Right. So I then have WSL installed, and I have Docker Desktop installed. And yeah, so that's how it works for Linux, for Windows and Mac. You can also get it installed for, I think you can get it installed for Linux. I'm not 100% sure, but I generally just prefer to use the command line, and that's where I'm sort of going to be going over. How many of you actually have Dockers installed right now? Can I get a check in the chat? Actually, no, let me ask the question. How many of you don't have it installed? That's more important. Nope. Doesn't matter if it's stable or Edge. Go with stable because Edge is gonna like be more buggy. No. Okay. What if I can only get the older version? What do you mean? Don't really know what if I can only get the older version, like from Toolbox? I have no idea what that is. But like, if for example you're running either on the terminal or using PowerShell, I'll just zoom in on this as well. 24, okay. Yeah, it's not nice. Yeah, so it's really buggy and weird on Windows because it just came out like fairly recently. I think it was like, yeah, it was like 4 days ago. So I'm not going to be personally using Windows for this thing. I'm instead going to be connecting to one of my Ubuntu servers and sort of doing the whole workshop over there. Yeah. So there are online sites like labs.playwithdocker, which essentially lets you host your own Docker environment, which is super duper fun. So let me actually just go to the website and give you guys a tour of how it's supposed to work. Right. So Play with Docker is when you go to it is just an online thing. You just go to it, you click on Docker, and it sort of asks you to authenticate. You give it your Docker information. I already have it because I created an account with them. And I hit start. Like, let me know if you guys want me to slow down because I generally tend to go pretty fast because I assume that everyone is just following along. So what I do is I create a new instance. So this is automatically going to launch a virtual machine for me that enables me to start playing around and doing some cool stuff with Dockers. So one of the first things right out of the box that I like to do on whenever I get Dockers is to obviously test out and see if it's working. And like any programmer will tell you, the way they like to do it is through a hello world program. So that's exactly what we're going to do. We're going to do Docker run hello world. So here are two things that I expect are going to happen. When I press enter, it's going to pull an image from Docker Hub, which I'll talk a little bit more about after this, once it's already done. and 2 is going to print out a nice little hello message for me. So let's go. Right. So it worked out pretty nicely. Step 1, enable to find image hello world : latest locally. What this does is essentially it's checking to see whether or not this image exists, so it doesn't have to like download it every single time. And the second thing that, and then it immediately, once it's not able to find it, it searches for it on the internet, primarily Docker Hub. Docker Hub is like a GitHub repository, but for Docker images, where you can push the most latest stuff that you have, and just make sure that it works without any problem. Yeah, and just like push it over there so it's like easier to work with. So let's say I'm looking for a Postgres database, and Postgres database. And I hit enter, and I start seeing all of these amazing images that come up. Some of them have different functionality for them. For example, this one is working with Nancy. Some of them are set up for the Circle CI, which is a pretty popular continuous integration tool, blah, blah, blah. But I'm interested in the official image, the juicy, beautiful stuff. And I click on it, and I saw that it was updated literally 20 minutes ago. It showed on the previous page. And you can see that there's a quick reference and all of these things with it. So if I want to run a Postgres virtual machine, I can, for example, just like copy this psql command. I can literally just copy it. And first, let's just check whether or not Postgres is installed. So psql. Let's hit enter. Command not found. Postgres. Generally, something shows up when you type stuff. So let's just paste that command that we found, and let's hit enter. And it will find the image, pulls the image, and then immediately should just bring us up into a network, some network not found. Oh, wait. Let's ignore the network stuff because we don't want to get into that. Host some Postgres. Sure, let's run that now. I think I'm running on the wrong stuff. Postgres run and paste. So password is going to be the most powerful thing called password. And -d Postgres -name server test. So Docker run name server test. So this is going to be the name of the actual container, which I'll sort of explain a little bit more in -e Postgres password is going to be password, and -d is going to be Postgres. So it immediately starts the container, and you can actually see it run. You can do Docker container list, and you can see that the Postgres instance is actually running. So yeah, so now we actually have a Postgres server that's up and running. Pretty nice, huh? And if, for example, I want to do, one second, container list, and I want to bring the instance back down, I can just do Docker container stop and server test. And that's the actual name of the image. Yeah, that's the name over there of the actual instance that I'm running. Sorry. And that's the name of the actual Postgres server that I'm running. So I can just do Docker container stop test server. I can bring it back up, Docker run -name server test password Postgres and -dp SQL. And now I'm going to specify to actually expose the port -p5432 to 5432. So this sort of comes back to how I was talking about before, that these Docker, that you sort of have all these Docker images that are contained within themselves, and how they work together. And so I just hit Docker run -p is already in use. Oh wait, I gotta. All right, because it's actually running the same name. So server test _2. Right. So that was weird, but let me just explain. Docker container. I can't type. And then there is. I thought there were supposed to be all of them. One second. Docker container ls. Exact same thing. Right. So over here we see that the Postgres database is working. Let me look up quickly how to, 1 second. So I'm just going to look up really quickly how to connect to it through PSQL. I can always just do apk add PSQL, and this will just install, and that's supposed to work, but it's not. Let me just look it up really quick. This is not a version of Linux I generally work with. I usually stick to Ubuntu or Debian because that's just what I use professionally. Fine. 1 second. Like, honestly, a lot of this stuff is just looking stuff up, which pretty much can be applied to the entirety of programming. Haha. I think this will work. Sure. So docker run -t name Postgres. Remove the network stuff. Yeah, crashed it. Yeah, this is also one of the more annoying things about Dockers is that sometimes when you're doing a Docker run something, and you forget to put -d, which is detach, it'll automatically just keep you there as hostage for the rest of time. Not that fun to see generally. So what's a fun thing I can actually show you guys? Because I know seeing the database itself is going to be kind of boring. Let me look up some cool Docker images. Yeah, by the way, this is probably running on Alpine Linux. You know what? I'm just going to go ahead and do it with Python and not worry too much about this stuff. So first thing I'm going to do, make directory is python-app.py. Sorry, I made a directory, not a file. Make directory Python app, cd Python app, and ls. So I can sort of see that there's nothing over here, and I'm in the Python directory. Now I need to install my editor. I'm just going to stick to Nano, which is a fairly basic and pretty user friendly. I don't want to go into Vim or Emacs or whatever. So that's apk add Nano, and it installed pretty quickly. So I can do nano app.py. I hit enter, and now I'm going to start building a very simple Python hello world app. So it's literally going to do print right. So I can do ls app.py, and I can do python app.py. This should not work, I think, because this doesn't come installed with Python. Exactly. So does Python exist at all? Nope, does not. So I can install on this machine, but then when I go to my production server, it's just probably not going to be up there, is it? So what I end up doing then is I can either install Python on this, which is apk add Python. I think 3.6 is necessary. I'm not sure. Python? Yeah, I'll install Python Alpine. On Alpine, yeah, I'm getting all the Docker stuff because literally everywhere you go, like when it comes to Python and on an Alpine Linux system, it's always you're going to be using with Dockers because of how efficient they are generally. And those images are fairly small, but no matter. Nano Docker file. So from Python 3.6 or 3.8 because it's the most latest one, what I do is just run cmd Python app.py and also copy app.py to app.py. So I'll go over this line by line just to make sure that it sort of makes sense because I just literally typed it out. First line from Python 3.6. Remember how when we did the hello world thing, it literally just pulled the image, did some stuff with it, and just exited? Same concept over here. When we build the Docker image, what it's going to immediately start doing is pull the Docker image from Python 3.8, copy our app.py file to its context, and then just run python app.py. So, hope this makes sense. Anyone have any questions at this point? Go. All right. Is it because I'm terrible at explaining stuff, or is it because I'm actually doing a good job? Dead silence. Okay, that's always reassuring. In that case, I'm just going to keep going. Yeah. So, save modified buffer, yes, hit enter, and now I can just do cat docker file, and I can actually see what the contents are. Now I do docker build -t. So I'll go over this whole thing like after I'm done typing it. Hello world Python, because you have the other image already installed over here, and we give it the doc. So just to go over this line by line, docker build. What this does is that it builds our Docker image for us and starts, so we can actually do stuff with it and improve it as time goes on. Then we do -t, which is hello world Python, which essentially just assigns this Docker image a name for us to actually use and work with. I hope that sort of makes sense to everyone? It's essentially just like how Postgres is named. So if I were to do Docker run Postgres, it'll just literally pull the image that we have for Postgres, and so it just runs that thing. And that's sort of like how when I do Docker run hello world Python, it will immediately just run the file without any problem. So ls, and we have docker file app.py, and now I can do docker run hello_world, and it's going to ask me, and I'm going to say, yeah, hello world Python, and I'm literally just going to run this, prints out hello world. Pretty decent, right? And we don't even need to look up how to install Python on Alpine because on this operating system because we're doo-doo heads and we don't know how to do it. Haha. So it works pretty nicely. I'll give it that. But this is sort of boring as an app.py file. And generally, the Docker file isn't supposed to be here. It's supposed to be in the previous directory. So this is our file, ls. Actually, let's go back to Python app and create a make directory src and move app.py to src \. So it's sort of how you would set up your GitHub repository in which you have a Docker file, which essentially is what you use to build stuff and work with deployments and stuff. And then you have your Python-app, which is generally named something cooler like NumPy or something else that's cool, like pandas or matplotlib. Actually, if you go to the NumPy GitHub, it should actually show up over there. Like you can sort of like get an idea of the structure for it from the thing. Is there Docker? No. NumPy. What library would use it? I'm going to look up das GitHub. So Dask is a very, very popular library for parallelized and distributed computing, with the main goal being just working with big data. It's got a lot of the same or similar functionality to it as other libraries. Yeah, it's got a lot of the cool functionalities and stuff for like what NumPy and Pandas do. The only difference being that this does it on a massive Hey, can you guys hear me? All right, I think I see myself on the chat, so I'm going to assume you guys can hear me. All right, so sorry about that. I didn't take into account my phone was at 50% at the start of the stream, but whatever. Yeah. So what we're going to try doing now is just have our. I was showing you guys how this is a really powerful library that uses that essentially works on Python, and we're sort of going to be copying the same structure. Blah blah blah. What's interesting about it? I was trying to find like some programs or whatever that actually have a Docker file in them. I can't remember which ones have them off the top of my head, but it is very common to have one. Dirt simple. Yeah, Dirt simple Postgres API. This should have a Docker image. And all right. So having some trouble remembering it. I did not expect us to actually be this quick with most of the theory stuff. I thought people would have more questions or whatever, so I didn't start preparing this part of the presentation or the workshop. I was going to actually do most of this stuff tomorrow. Yeah. Official images, blah, blah, blah. All right, whatever. So back to Docker Playground. So what you see is that we have our Docker file, our Python app. This follows a pretty good structure to how most GitHub repos are set up with. So now what we want to do is try adding some functionality in the Python app to maybe work nicely with like an external package, such as Flask. Sorry, 1 second. Right. So the first thing we got to do is create a requirements.txt file. So that essentially just contains, like, I hope all of you guys are sort of familiar with Python, so this next part becomes a little bit easier to explain. So Python essentially requires you to have occasionally requires you to have a requirements.txt file, so that whenever you do try doing something, it just works out of the whenever you try installing something or working something on a separate deployment, all the packages and stuff are working right out of the box. So the first one, the only package that we'll sort of be using for the rest of tonight is going to be the Flask package, which works pretty nicely. Yeah. So now we can do cat requirements.txt. Pretty nice. So now we've got to modify our Docker file to work with the requirements.txt file, and to do that, we're simply going to be doing copy dot. So what this is going to do is everything in this directory copy it over into the Docker context, just to make it work, and then run pip install -r requirements.txt. So from Python 3.8, we're going to import the stuff, then copy everything in the given directory to this directory. This is sort of bad practice because we're copying everything. You're supposed to only copy like the stuff that you actually most importantly need, but since this is like relatively small, it should be fine. Otherwise, what you can end up copying is just do copy requirements.txt to requirements.txt. First one is what exists on the local machine where the Docker file is kept. The second one is on the actual Docker context itself. And then the second one would just be python-app to python-app. So what this does is that we install all the requirement.txt files, and then using pip. Pip is the Python packaging index or something along those lines. I forgot what the actual name is. package index Python, whatever. And then run pip install -r requirement. So we can have like anything over here, and it would just install it right out of the bat. And then we have command python app.py. So we exit out of this, and we do our Docker build again. Docker build -t hello world Python, and current context, sends the context to the build daemon, copy requirements, does the thing, install, copies Python app to Python app, installs the requirements.txt, which only contains Flask right now and all of its dependencies, and then sets the command to be run to python app.py. So now we're going to run docker run hello world Python, and boom, still works, right? So yeah, that's pretty cool. Let's say, for example, that I had a complicated setup where I'm trying to do some image processing or some interesting NumPy function. Just to keep things simple, I won't go too much into that, but it'll still show you how. But it's sort of like how you can sort of like run all those operations with this stuff without any problems at all. Right. So, so let's modify our code to actually showcase some pretty cool stuff on the Docker. Yeah, to actually showcase some pretty cool stuff and show you how it's going to be working for a backend, for example. So let's go to Python app and then do cd src ls cd app.py. Oh, that's supposed to be nano app.py. And instead of doing just a simple print hello world, we're instead going to be running a Flask application. And paste. So very simple, very straightforward. From Flask, import Flask, create the Flask application stuff. This sort of lets us, this just initializes it so it works as a Flask app. And then we define what the route is supposed to be. You'll sort of see what this does in a little bit. Right, so if you guys want to sort of copy that as well, I'll just put it in the chat. That should work. Yeah, so you can just literally copy that and paste it into your thing, and it should just work right out of the bat. And lscd, ls, yeah. So the host file, now we just do, we rerun the Docker build process. This time, something interesting is going to happen. What you'll see is that it essentially just installed everything. Like it started using the cache. So since we didn't update the requirements.txt, it didn't copy the requirements.txt because nothing changed. But it did see that there were some changes in the Python app.py, so it recopied all those files and reran everything that comes below it. This is sort of useful when you're sort of like setting up your builds to be working in such a way that only specific stuff from, yeah, so like only the first few builds, for example, would end up like being skipped, and the ones that you made the changes to don't. So if I were to make some changes to nano, the Docker file itself, and instead set Python 3 app.py or whatever, it would not have to reinstall the packages or whatever. It just works pretty nicely like that. So we built it already, right? Yeah, we built it. So let's run Python. No, let's run Docker run hello underscore world Python, and then let's specify that we want to apply the -d option, which would detach it from our screen, meaning that we wouldn't end up, I think it's supposed to be over here, -d, which means that when the program is run, it automatically detaches so we don't end up seeing it the entire time and don't run into the same problem. Really hope this works out of the bat without any problem. Otherwise, I'm going to have to create a new instance. Okay. 1 second. just want to be sure about this. Because it's sort of it should work. So Docker run hello world Python. I run this and it's running, and now I can do Docker container ls, and we can see that that's change Docker ps. It might have literally just crashed. Yeah, so you can sort of see that this one just exited a couple of minutes ago. And we can sort of like explore we can look into why that's happening with Docker logs hello, actually 3.5. One second. Docker logs Keen Murdoch, that's what we're looking for. Murdoch, hello world. Nope. 23 minutes ago, 4 minutes ago, 38 seconds ago, 37 seconds ago. Right, I think I know what the error is. It's just a Docker file, and you're supposed to run python-app/src/app.py. And now we just rerun the Docker build. And Docker run. Actually, I'm going to rebuild this with a different name because last Python. Docker build does the exact same thing. It just noticed that the file name has been changed. Docker run. Flask_Python. And then the attached state. Yeah, it's definitely closing because it seems to be bugging out. Yes, class Python, Hungry Williams, so Docker logs. It's not showing the error log for some reason. Oh yeah, it's probably not running anything at all because, okay, I definitely know what the error is. So C, Python app, src, and nano, and app.py. I'm never running the actual Flask application. And the way you do that is if __name is equal to _name, we just do app.run. I think that should work. And let's rebuild our Flask stuff. And let's run it. Flask Python and container list. Yay! So we actually see it working without it immediately crashing. And it's not even crashing. It's just literally just like executing the script. So now it's actually working, and it works. And it's working, but what you'll notice is that there's no way for us to actually check out how it's working entirely. And that's because we need to add some additional configurations to it. So that's Python app, src, app.py, and then when we open this, we specify that the port equal to 5000, host equal to 0.0.0.0. As you guys may know, 0.0.0.0 is essentially the same machine itself, but sort of expose it. And then port 5000 is just a specific port. Like Postgres is still running on 5432. So we do Docker, and then we just like rebuild the image now. It does more or less everything again. And now we do Docker run -d, but instead of just -d, we're also going to specify port 5000 be exposed. So what this works is essentially internal port, external port, and it sort of enables us to monitor stuff that it goes without running into this is sort of like where I mentioned that we'll be exposing ports so that stuff can work right out of the bat. Docker run -d -p 5000 flask.python. It's working, and you notice that this thing sort of showed up. If I go to this website, it prints out "Hello World." Congratulations, you just built your first Flask application. Do you guys have any more questions? Because I was just thinking of maybe like setting up some quick Minecraft servers or whatever, because that's always fun. If you guys have any questions, let me know. And tomorrow's workshop is actually going to be much more interesting because I'm going to have the practical part actually prepared. And that's it. That's why it's going to be better. And you're actually going to be working on a like pseudo backend that's actually doing some cool stuff too. So tomorrow's workshop is actually planned to be better than this one. I did not expect the theory stuff to just like be that quick. So yeah, any question in the chats? Anyone? All right, so just to sort of show you guys how Dockers could be useful for some minor deployments, or in this case, Minecraft, which I have done in the past, is essentially you just search Minecraft server Docker container. This wonderful link shows up on Docker Hub for the official Minecraft Docker image. Over there, you sort of see like it's pretty popular because of how many stars and how many Docker pulls it's got. And then essentially it's like you can read the full docs for maximum configuration on GitHub. I've actually run a couple of pretty cool instances of this without having to like worry about settings or whatever, which is always nice. And yeah, so I'm literally just going to copy this and paste it. Ideally, you would actually like read this stuff, but yuck, reading, haha. And just hit enter, and it will find image locally, so it's downloading it and extracting on all systems. Yep. And now I can literally do Docker run or Docker container list, and boom, I assume that's Minecraft. Dash name MC. Wait, I think it crashed. Docker container ps -- filter status equal to Minecraft server start exited 1. Wonder why. Docker logs and yeah, MC was the name. Changing ownership. You must add the following immediately after Docker run. So Docker run -e EULA equal true. So this is just here because like the way a Minecraft server works is that you sort of have to specify that you're following its rules, and as long as you set this to be true, it should work. So let's run that again. Or used by container. So MC_2 because I'm too lazy to actually change the name. Right. So now it's actually working, and you should see Docker container list, and boom, it's actually working. And without any problems too. So I can actually go to this link right now, and it's downloading something. What I was sort of expecting was like some sort of like, hey, you're not supposed to connect to this way, or whatever. But hey, this works pretty well as well. So yeah, you can actually like have a Docker container listed out, and I think it's it's probably just testing out whether or not it's probably just like still starting off because it takes a few seconds to do it. You can also set up Docker volumes, which will sort of like, because Dockers by default will just keep everything running on its own. Yeah, like it'll keep everything running on its own, and it won't save anything to your local hard drive until you delete the instance, unless you specify that you actually want to keep stuff on it, which kind of important you want to do. Status 1 minute. So it's finished. It finished doing the finished starting, and it's actually like set up and healthy now, and we can actually get it working. So that's essentially the overall gist of the workshop. Tomorrow it's actually going to be much more interesting because we'll actually be diving into the practical stuff. I hope you get Docker installed. Otherwise, we might just stick to this and do everything through the command line. Do you guys have any more questions? We have about 5 minutes left on our workshop timeline. I'm going to try for a minute or two just to get the Postgres database working because I thought that was really cool. Yeah, but in a sense, this is the end of the workshop. Thank you so much for coming. Hope to see you on the one tomorrow where we actually start doing some cooler stuff on it, where we actually build our own backend / sort of pseudo mock website, connect to it with a database, and maybe set up a little sorry about that, and see how we can sort of control different stuff together, learn a little bit more about microservices architecture, and see how we can control all those things with a simple Docker compose command. All right. Hope you guys enjoy this one. Please be sure to fill out the feedback forms and have a good night.